The earliest black holes in the universe didn't need stars, galaxies, or planets to form. They could have emerged in a void, driven purely by energy. According to energy filament theory, the early universe wasn't empty space as we often imagine, but rather a massive, turbulent sea of energy, stretching, twisting, reconnecting, and in a constant state of chaos like a pot of boiling syrup on the stove. In this chaotic and extreme environment, black holes could form without the need for a collapsing star. Imagine a thick, dense batter being stirred rapidly by dozens of mixers. Certain parts of the batter get stretched to extreme limits, creating whirlpools, spinning cores, and even places where the surface collapses into holes. This process is incredibly similar to the way black holes form, but on a cosmic scale. In energy filament theory, the formation of primordial black holes can be explained by three key processes. First, extreme fluctuations in the energy sea. At the very beginning of the universe, the curvature fluctuations were massive. Certain regions of the energy sea were pulled so tight that they crossed a threshold and collapsed into black hole cores. These fluctuations were not a simple distortion, but a sudden shift in the fabric of spacetime, leading to the creation of these black holes. Second, the cutting hole effect caused by high-frequency shear. Different regions of the energy sea, with varying curvatures, acted like scissors that cut across each other. Where these forces intersected, closed loops would form, and once these loops were tightened, they became mini black holes. This wasn't caused by matter or explosions, but by the sea itself being cut and transforming into black hole states. It's an interesting twist in our understanding that black holes could form from sheer energy dynamics, rather than traditional materials collapsing. Third, the collapse points triggered by average gravitational forces. The early universe was teeming with unstable particles, and once their average gravitational forces exceeded a critical point, entire sections of the energy sea would collapse into black holes. This is the most common origin for primordial black holes. These particles didn't need to be drawn into a massive collapsing star. Instead, their collective gravitational forces caused the energy sea itself to collapse. Thus, primordial black holes are born in a way that is entirely different from what we typically expect. Instead of relying on stars or complex elemental processes, the energy sea itself collapsed into a vast, unfathomably deep hole. This process of collapse could have happened before the first stars, galaxies, or even planets formed, making primordial black holes potentially much older than anything we see in the universe today. More importantly, if there are enough primordial black holes scattered throughout the universe, they could serve as fundamental anchor points for the entire energy sea, shaping and influencing the cosmic web structure. These black holes effectively acted as the universe's early architects, laying down the blueprints for how matter would ultimately organize itself across the vast expanse of space. Contrary to what we might think, primordial black holes aren't just a concept from science fiction. They are the universe's oldest and most fundamental structures, carrying within them the secrets of the universe's birth. In the next episode, we'll dive deeper into what happens when black holes merge. How do they interact, and how do their immense forces generate the gravitational waves that travel across the universe and reach us? Stay tuned for more as we continue to explore these groundbreaking ideas in new physics and gain a deeper understanding of the cosmos. Tap follow, share it on New Physics, Clear Universe.